Okay, guys, we need to like actually start studying. So it says here that the eye has a transparent lens focusing light to the retina. The image of the retina is upside down, and the retina is made of like two cells, rods and cones. Cones are responsible for the sight of colors, and rods are responsible for the depth perception, night vision, and peripheral vision.
Huh? I thought we were talking about taste.
Julia!
Y'all know that we have 10,000 taste buds in our tongue?
Oh my god.
What are y'all talking about? Who knows? Okay, well, it says here that the outer ear is the pinna that sound funnels through into the external auditory canal. The middle ear is a small air-filled cavity filled with the temporal cavity that has the stapes, anvil, and hammer. And the inner ear is a maze of bony chambers called the bony labyrinth. It's split up into the cochlea, the vestibule, and the semicircular canals that's filled with a plasma-like fluid called perilymph. Literally, okay, what does that mean? I'm literally gonna get a 12 on this test.
Okay, y'all, it's okay. Let's focus, all right? So it says here that we smell because of the olfactory receptor cells, which are neurons equipped with olfactory hairs, which are like long cilia that protrude from the nasal epithelium and are continually bathed by a layer of mucus secreted by underlying glands. Does that make sense?
No. Okay, great.
Okay. When the receptors are stimulated by chemicals dissolved in the mucus, they transmit impulses along the olfactory nerve to the olfactory cortex of the brain, apparently. And the olfactory pathways are closely tied into the limbic system, where odors recall memories and arouse emotional responses, which is why like certain memories are tied to sense of smell. You know? Get it? Yeah, that stuff doesn't make any sense.
I understand it. Kinda.
No, you don't understand it, Julia. None of us understand it.
Wait, guys, I actually kind of understand that. The nose is far less acute than that of many other animals. Thousands of olfactory receptors for the sense of smell, occupy a postage stamp-sized area in the roof of each nasal cavity. The olfactory receptors are smell receptors located in the superior part of the nasal cavity. Do y'all get that?
Yeah. We still have 4 other senses to study.
Oh, you guys, listen. When we taste things, we're tasting or judging our environment in an intimate way.
That's not funny.
All right, guys, we're going to study flashcards now. Here we go. Where are the taste buds that allow for the sense of taste located?
Oh, those are the ones that are like scattered around the oral cavity, right?
Good. I think. Good!
Yeah.
Where are the rest of the taste buds found?
On the soft palate and the inner part of the cheeks.
Julia, that's wrong.
That is so right.
No, she's right.
Can someone DM Mr. Williams on Instagram and ask him if that's the right answer?
He already responded. And he said, sorry, I'm not available to respond on weekends.
We're screwed.
Oh, wait. He responded. Okay.
Praise Jesus! What did he say?
He said, remember that there are papillae, or small peg-like projections that cover the dorsal tongue surface. There are 3 types: sharp filiform papillae, rounded fungi-form papillae, and circumvallate papillae. And he reminded me about the gustatory cells that are epithelial cells that are specific cells that respond to the chemicals dissolved in the saliva. Gustatory hairs protrude through the taste pore, and when they are stimulated, they depolarize and impulses are transmitted to the brain.
Did he actually give us an answer to a question?
That's too good
I
to
don't
be
think
true.
that's
right.
Wait, ask him more questions.
Okay, ask him about the function of the ear because that confuses me.
Okay, he just said don't ask him any more questions.
Oh, wait. I found this. It says that detected by the ear, and then they made into nerve impulses or action potentials that are perceived by the brain. Outer and middle ear is involved with hearing only, but the inner ear involves functions with hearing and equilibrium. Eustachian Eustachian tube. Eustachian tube equalizes air pressure in the middle ear with the air pressure in the atmosphere and helps humans retain their balance.
Heck yeah, write that on a flashcard. There's two more, touch and sight, and I don't understand either, so.
The optic nerve is used to send senses from the eye to the brain. And the point of connection of the optic nerve and the eye is called the blind spot. And it's called this because no light is received there. So basically, the iris contracts in the light to limit intake of light and expands in the dark. The spectrum of light goes from red to violet. Infrared electromagnetic frequencies can sense heat as well as UV, but can't be seen. So color blindness is thought to be caused by like faulty cone cells in the retina, apparently. There are 3 cones, one to detect red, one to detect blue, and one to detect green. Kind of makes sense, right? No.
Okay, let's just keep going. We have one more sense. Touch. Can we figure that out? I don't understand. Hello?
Great.
Oh, wait.
Let's just keep going.
Okay, go.
Let's just keep going.
What receptors are the most numerous and called polymodal, meaning that they have multiple functions? They perceive pain, temperature, pressure, stretch, and itch signals.
Free nerve endings.
Yeah!
These are mostly high-frequency vibration signals and joint position changes and rapid changing pressure.
How do you say it?
I don't know.
Ask Siri how you say it.
Pacinian corpuscle.
Yeah!
Those
That was good.
The light touch, like our lips and our finger pads. Vibration and stretch helps us feel detailed textures, you know, like while braille.
Okay. Massiner's corpus.
Pacinian corpuscle.
Is that right? Is that right?
Yeah.
Yeah, okay. Good.
What's the one that helps us determine if something is moving on our skin? Like when something is like sliding out of our hands.
Ruffini corpuscle.
What do Merkel cells do again?
Those are the ones that help us feel like the edges of like the shapes.
Okay, so how does the feeling work?
Okay, so
then?
signals from touch receptors travel along peripheral nerves which connect to your spine. The spine then directs the signals to the brain, where the signals will be processed in the corresponding parts of the brain. Where this meets clinically application is how our receptor-based rehabilitation specialists alter the amount of information traveling from the receptors to the parietal lobe.
Yeah, I still think I'm gonna fail.
I think we all are.
Oh well. In action. I brought macaroons. Julia, you're an hour late.
I brought macaroons!
Okay.
You look really weird.
Help!
I don't understand.
Wait. Start again. Okay. I'm sorry.
Julia.
Corpuscle.
I don't know. Yep.